Hello there, my name is Fabrizio Chamon, and today we'll learn how to create this kind of cool spreading or infection effect, whatever you may call that. And I think it's a very common, very used effect. And actually, there are a lot of materials on the internet covering this kind of effect. But that's my take on it. And also, I'll try and go a little bit further with the controls. So that you have something more directable, and also I'll try and do the whole thing from zero to building your own digital asset. Okay, so before starting Houdini, let me go to Photoshop and talk about some premises that I'm thinking about for this effect to work. And the first one is that it shouldn't rely on topology, and of course we are going to work on scattered points. And the second and most important premise is that it should be, of course, art directable in some way, meaning that we should be able to paint like a contamination threshold direct on the mesh, so that you can drive the effect and have like veins or leading edges. And also we can use texture maps or blend both, really. And also we should have some kind of post simulation controls, and that will allow us to retime our simulation, and also to do some blurring and edge detection features, so that we can maybe like do a ring around our effect and emit particles from that and stuff like that. Okay, so let's get back to Houdini and lay down some simple geometry to start. The first thing is we have to scatter points over the geometry, so let's start with that. Scatter some points, and very simple, let's define our starting point. We're going to create two types of initial states, and the first one is where you select some points and say like that's where I want the effect to start growing. And the second one is where you input some points and that you do some search radius around that, and all the points that lies inside the radius will be the starting points. Okay, so the second one will be better, will be a little bit better, because we don't rely on selecting point indices directly, but rather we are selecting by positions or by areas. So you can then later on change the number of points, and it won't affect your initial state. Okay, so let's do the simple version for now. So let's create an attribute Rango, and let's define our starting points, and for that we should drop a group, and that would be a point group, and let's select like this point. Okay, so I'm going to call this group starting points, and now we are going to set our starting infection. So running over the starting point group, so let's call that f start infection. Okay, and also I'm go and color that. Actually, let me color Rango. I'll call those color infection. So let's say our CD would be our infection 0 and 0. So we are going to color the points red, the infected points red. For now we won't see anything because we don't have any infection going on, we just have the start infection. And now we are going to solve things. So the important thing to say is that the solver you should pin the viewport before going inside the solver, so that you can see the result, because once you are inside the solver, sometimes it doesn't work when you play, it doesn't show up. So one level before and just pin the viewport at that level and then just go back. And also it's going to be good because we are going to color our points as we solve this stuff. Okay, so now we are going to drop an attribute wrangle and let's call that solve infection. Okay, so how the infection is going to work is we are going to PC find or sample points. Let's say for this point we're going to sample around the radius and try to find any point that has infection value other than 0. And once we find that, we are probably going to average all the point values and somehow modify that to add noises and stuff like that, and then we finally set the infection on the self point. Okay, so let's do a very simple thing before, and let's make that another attribute wrangle before the solver, and I'm going to call that set infection. And that's going to do is to set the infection to 1 on the starting point, and we'll see that you have your first point red. Okay, so let me open the display options and up the point size a bit so that's easier for us to see. And that's our first point red on the corner. So let's solve that, and for that we are going to set the infection, so float infection. Actually, let's first PC find, and we are going to PC find. So the PC find function expects the geometry, which in our case is 0, and the second argument is the point channel, which is the P, and it's a string channel. And the third one is where we are going to sample from, and it's also P, but now in form of an attribute. And then we need to pass over the radius. So for that we are create the radius and max points we are going to create with channels. So the first one is a float radius, so let's call that float search radius, and that's going to be a channel search radius. And the second one will be an integer called max search points. That's going to be a channel integer max search points. So we're going to pass over the radius and search points. So that will return us an array of point indices, and so we are going to call that PDS bit indices, pass the brackets so that VEX knows it's an array, and that will return our points close to the one we are iterating. So with the indices we can do a for each loop. So go for each. For it we are going to create an integer called pt, and that will run over the pt indices. So for each point we are going to look up for the infection value. So we're going to say that let's go very simple before. Let's just search if any of the neighbor particles has an infection value. It's going to automatically contaminate with the infection of that point. Okay, so if point, because we are going to ask for an attribute on this geometry, so point first geometry f1 on the function, again just to check the spelling. So geometry, attribute name, and point number. So we're going to sample to look for the attribute infection on the point PT. So if actually, let's put that into a variable. So float neighbor infection would be that value, and if neighbor infection is 1, then we'll contaminate ourselves. So infection will also be 1. Okay, this is the simple stuff we can do. It's complaining because I believe I don't have open the okay. So now we are going to search around the radius, and if the point has one neighbor that is infected, it also going to contaminate this point. Okay, so let's create our channels, and let's up the search radius to 1 and the max points to, let's say, 5, and let's play that, and we see the points there is contamination going on, and you can play with the search radius. So let's say we want just this value, so it's going to be slower, and it also is going to miss some points, as you can see here. So this is a very simple version. Actually, let's up the point count a bit, and you see why I want to provide a point to as a starting. I don't want to provide a point as a starting infection, because if you change the point number, let's say we want 10 times more, you see that the infection starts from here now, when I wanted it to start from here. So what I like to do is to provide an arbitrary point and search from that. Okay, so just for the moment, let's set that back to this little corner, and also down the size a bit. So here you can see it already works nicely. But let's say we want to paint the overall multiplier on how it should contaminate. So let's paint. Let's do a paint on the grid. Maybe we should subdivide that before painting so that we have more geometry. Let's say like this. And then we are going to paint a value that is called infection mode for infection multiplier, and we would like to visualize that range and as a grayscale. Okay, so let's first paint out with a black color, apply to all, and then let's paint like a path. So let's do something like this. Actually, not like this. Let's do some line. And let's also attribute transfer that back to the points. So after the scatter node, we can attribute transfer that. And we are going to transfer the infection multiplier. Let's rearrange things here. Okay, so if you go to the solver, and instead of using right now we just check for neighbors, and if it has at least one with infection value of 1, it automatically contaminates the point. But we are going to make it different. We are going to sum all the points, all the infection on the neighbor points, and do an mean value. We are going to average those points. So for that, let's create a float, a variable called infection sum. We'll start with 0, and now we are going to, at every iteration, we are going to sum. So our infection sum plus equal neighbor infection, and after we have all the sum, we are going to divide. So let's call that average infection. That will be the infection sum divided by the number of elements, so the length of pit indices. That will output us an average weight. So this new value will be going to be our infection. Let's see how it behaves now. So you can see it's kind of working, but it's very subtle. I'll have just a little bit because it's averaging at each frame, and what we'd like to do is that we would like to increment our infection and not set that. So now you can see it's going to output like an edge. We should not run the code on what is already fully infected, otherwise we are going to get this edge. So for that, let's check before everything if infection is less than 1. So if our infection is less than 1, then we do the whole thing, otherwise we do nothing. Okay, so let's play that again, and now you can see we have like a softer edge because that's not 0 or 1, that is incrementing slowly. And now what we can do is multiply this value for with the painted contamination threshold. So we call that infection multiplier mode, and let's do that right now. So if we just multiply directly by our infection mode, and if you play that, you can see it follows the painted map or the painted attribute. Okay, but the other points stay black because we are multiplying. So if we have everything that is pure black, it's not going to contaminate. So we may change that in two ways. The first one is that we can add to the map, add to this map some kind of turbulence. Let's try that. So we'll do infection multiplier will be incremented by a noise, and let's give it a point as a seed, and also let's control the frequency and the amplitude with channels. So P times C channel frequency, and that all will be multiplied by another channel called amp for amplitude. So if you visualize, let's add some amplitude and some frequency. So here you can see we have added a little bit of randomness, And also we may want to contrast that that noise a little bit just to check the effect. And for that we are going to do one thing, that is, let's define this noise as a float before. Noise add, and we are also going to contrast that, and to contrast that noise add, we're going to fit the noise add itself and start from min and max, and it goes from 0 to 1, and it throws me an error, and that's because we missed some parentheses here. And what this does is let me go back to this noise add. And what this does is going to allow you to crunch, to contrast or compress the colors. So if you do something like this, you can contrast. Sorry about the noise. There is I live next to an airport and there are planes passing all the time, so sorry for the noise. So here you can compress these colors, and let's see what happens now. So you can see it started looking for other areas, but then again it reaches a moment that it stops. That's because we have 0 values, totally black values here. So we can try and actually change this attribute. Let's call that turbulence infection multiplier. And let's remap those values to new values. So let's call that output min and output max. So we initially go from 0 to 1. Let's add just a little bit for the minimum output, like 0.1, and let's lessen the noise a bit. So now we have this, which is already working nicely. So you can see it spreads nicely through the geometry. But let's take it a step further, and now let's try and add something on the solver, and that will be the minimum contamination or the minimum infection value that will be needed for a point to contaminate itself. So let's add that. So if the average infection or the sum of the neighbor infection values is greater than or equal some value, let's say for now that we'll create a channel for that. Let's say min let's call that min contamination. So only if we have a minimum contamination threshold reached, we are going to contaminate. So what is this telling me is that we again miss parentheses. So now we have minimum contamination, and if you play right now, it's going to contaminate. But if we tell that the minimum contamination of the neighbors for it to spread, it needs to be 0.8, then we will have something like this that is not going to contaminate, and we can go down a bit, and let's say 0.5. 2, and now you can see we have a different effect because it waits for a limit to be reached before contaming the points. And I think we can move on to something like blurring the result. So what you can do right now is to attribute blur the infection, so we can blur that, and also influence type should be proximity instead of connectivity, because we don't have a mesh, we have only points, so we don't have information to connect those, so it should be based on proximity. And here we can define the blurring iterations and proximity radius and stuff like that, so we can do a soft nice and soft edge to our contamination. And the another step is how to output the edges of this, which is going to be used for emitting particles or other interesting effects. And let me zero out the blur iterations. And there is a very naive technique, but it works for when you have like simple values. That is, let's create an attribute Rango, detect edges. That is to do a blur and blur on the attribute, and then check a value that is between a specified range that sits around the 0.5 value. So with this you can like define a small amount of points that will participate on this effect. So let's again let's blur the thing. Let's blur that a bit, and let's just keep points. So let's only keep the points. So we'll be removing points from self, and let's check the function arguments, gel handle and point number. So we are going to remove points, and that will be ptnum. That will remove all, but we are only doing that if our infection sits between its greater than, and let's create a channel called min. We can rename those channels later, just calling everything min and max, but it's easier to follow. And so it's greater than min, and it's infection, it's less than max, so if this is greater than, let's say, 0.5 and less than 0.6, we're going to delete. And there's a very simple technique and very naive, but you see it works. And the larger the range, the more thick the edges. So you can check here. So this way we can output the edge of the thing, and we can use that for any stuff you need. So let's do that as an attribute, not delete. So let's call that, and also we should do the blurring as a separate process, because we want to blur for the result, and we want a different blur for the edge detection. So what you can do is to set that as an attribute. So what you're going to do is, instead of moving point, we are going to set that as an edge. So let's call that infection edge. And we are going to transfer back this edge attribute to the original point. And for that we can attribute copy. So we are going to copy the infection edge attribute. Okay, so here we can see the infection, and we can also see the infection edge if you want to. Let's use that as a green value, and here we have the edges. Okay, so infection, and we can also blur that if you want to. So infection and edge. Okay, so let's move on. And now I want to change how we input the starting points. Instead of setting the value direct on the group with the point indices, I'd like to use arbitrary number of points. So let's create an add node, and let's check one point. Let's put that to the side, and let's drop an attribute wrangle. And we are going to use this result and also the add node, and let's call that set start point group. And for that, what we want to do is to PC find, and now we are going to find on the second input. We are not going to find on itself, but rather on this point. So we're going to find in the second group on the P channel P attribute. We are going to start looking from the P attribute, and we are going to give it search radius. And finally, the maximum points it should be just one, because if it finds only one point, that's all we need. So we don't need more than 1 point in this case. So that's going to return array of points, point indices, and if the length of our PTS array is more than 0, then we should set the group starting point to 1. Okay, so remember, if you create an attribute that starts with group underscore, then it creates a group. Let me also tell that it's an integer, so it's going to put that in a group. And to test that, let's go to the viewport and ask let's also, before, just put the search radius of 1, and let's test that, and we see it's working. And if we tweak the radius, it's going to search for this point. And the beauty of this is that we can go and modify the total number of points, and it's always going to search from the same starting positions. So we can let's reorganize things here, and I'm not going to get rid of this group node, but rather we will be using a switch, so we can define that if we want to pick directly the point indices or the points on the viewport, or if you want to add this kind of control. All right, so let's make that 0 and this 1, and we go to the start infection, and let's go back to the beginning. And for now we are using the fixed points, but let's go to 1 and let's use this technique. And also let's up the search radius. It's not working. Starting point, because I miss it's not the correct name. Now it's good. Let's check that. Yeah, working. And let's turn down search radius a bit. Okay, so let's put another point. This one will start more on the left side. Let's check that again, and you see it works. And if you play right now, so different result once it reaches our painted map, it starts to spreading faster. So let's also test with a texture map, and for that we can go to this paint map, and we can let's, instead of painting a map, let's try and do an attribute from map. Where is it? Attribute from map. Okay, let's try and find a texture. And let's use the circle, for example, Houdini the full circle, and let's export that to infection mode. Use that as the new attribute, and let's check what happens. And you see now that we don't have that randomization noise going on. We're just going to spread over the texture, so you can see it creates a border. And maybe we can blend between the two, so we can do an attribute, or rather, let's make an attribute Rango for that. So add infection mode. So what you can do is to set the infection mode to be add to itself the point attribute from input from the second input, index 1, and we are going to search for the attribute infection mode, and we are going to search for the PT9. Okay, so we're adding both maps. Let's visualize that. Actually, this already does the visualization thing, and here is the blending or the sum of the two maps, and we can also claim that value to stay in the 0-1 range, so we can clamp that from 0 to 1, and let's see what happens. So it spreads, forms the circle, and also follows the line. Now everything it's blending together, so we have the effect less visible, but we can have many controls, or we should have the option to use one or another. So you have a switch here, and here we are going to say that actually the first option would be to have a map, this map. The second option is to have the texture, and the third option is to have the sum of the two. So this way we can control that to best fit our needs. Okay, so the next step is to retime the whole thing. So let me do this so that I have just one stream, and we'll do a time warp for that. Actually, let me put that after the visualization. So right now this is what we have, and let's say we want to make this effect like 2 times faster. So what starts at 1 and ends at 100, we want to start at 1 and end at 50. So we're doubling the speed here, and the post extend should be extend so that it doesn't clamp. So now we have the effects 2 times faster. Okay, and but of course we don't want to fiddle with random numbers. We want to put like 1 time times the speed, or 2 times, or 3 times, or 0.5. So for that we're going to set an expression for this, and let's maybe create like a no or something, and let's call that speed controls, and speed control, let's color that yellow, and let's add a float attribute called speed, and default to 1. Okay, so this expression will be 100 divided by this value. So it's very simple expression. Paste relative references. So we can see that speed 1 is the default speed, and if we put 2, it's going to be twice as fast, and we can control that. And you can see that you are going to be simulated frames ahead. If you put also, let's try lower the speed. Let's put 0.5, so that will be a lot more slower. So yeah, this is a nice and quick way you can control the speed. So very fast. Let's put 10 times. It's super fast. This is a very neat way to control the speed, and very easy to. So we have the time warp working, and let's do another thing, that is having a visualizer for the colors. So we have a switch, and so we have color infection, color the edges, and I also like to color the starting points. So we're going to set to 1, and we are only working on the starting points, or actually let's make the rest black. So we'll do group starting points. So now we have everything black and just the yellow starting points, and we are going to switch that so we can see the starting points or the infection itself or the infection edge. So here you can see we have a nice visualization tool for our spreading effect, and that's going to be plugged into the time warp that goes together with the speed controls node. Okay, so I believe this is reaching a level that we can already start creating our digital asset, and let's do that right now. And what I like to do before everything is to put a null on the two parts, the beginning and the end of the tree. So I'm going to call that in geo, and I'll color that green, and I'm going to put another null at the end, and let's call that out points. Okay, so those are the points, and also I'll try and also output the infection attribute mapped to the original geometry. So to do that, we're going to attribute transfer. So let's take the result of our in geo, and I'll hold Alt and click so that we can organize our tree that is starting to become too big. So Alt click again, and let's make that let's make an attribute transfer. So we are going to transfer the infection attribute to our initial geometry, and we are going to output that to another node. Let's call that alt init geo, and let's visualize that. So what we're going to see is the infection attribute mapped to the original geometry. So you can see that we don't have enough resolution, but anyway we have our thing mapped, so you can use right off the shelf if you need. And yeah, okay, so let's make that into a digital asset. So I'm going to select everything but the first node, the geometry node, and right click and click the subnet. So spacebar G, and we have now everything into a subnet. Let's call that my infection. So let's right click and create digital asset for that. Now I'm going to call that my infection and label my infection with space, and I'm going to save that on my Houdini hotels, my infection. Okay, so accept that. So now we have the digital asset window, and we can define some stuff here. Let's go to the basic tab, and we have label and the icon. I'm not going to change the icon for now, just to use the default one, and minimum inputs will be 1. That is the input geometry, and the maximum outputs will be 2. 1 for the points and 1 for the input geometry with an added infection attribute. So we'll have 2 outputs. So we're going to let's apply first and accept, and you see that you have one input here, but you have no outputs, so you have to create those yourself. So I'm going to create an output node here. It's be index 0 or points, and the second output is index 1. It's going to be our geometry. So by default I want to see the result of the points. So here you have both, and I closed the window so I can reopen that again by right clicking and type properties. So now we have two outputs. I'm going to the input output tab just to label things. So the input label is the input geometry. So the output one will be the infection points, and the output 2 will be the like the input geo with attribute, or rather input geo with infection, so that's easier to read. Okay, so let's start promoting our parameters here. So what I need to do is let's check what we want the user to be able to change. First thing is probably how he wants to initialize the points. So let me do one thing first, is that to cut this add node. So I'm going to put that outside the digital asset, and let me add one input port here, and let's connect that, and finally use that as our second input. This is so that we can choose to either use that or not. And also let's name things. So let's call that input geo, input start positions, infection points, and input geo change it, okay, for the input and output labels. So let's apply, and let's start promoting our parameters, and I'll create a folder. Let's call that init for initial configurations, and another folder, or actually let's use an order menu. Let's call that start points mode. So start PTS mode, and that will have two options. The first one is going to be by point indices, where you are going to select the points directly on the mesh, and the second one will be by init positions. Okay, these two modes. So if we go back to our digital asset, we have a menu with two options, and for the first one, that is point indices, we'll have another folder, and this will be of type simple, and let's call that point group. And here we are going to expose this base group, and before that we are going to create a null here in between right before the group. Now I'm going to explain you why is that in a second. Let me just rename that, pick group, and for the group node, let's expose the base group string. And if you use this right now as it is, you have an error, and that error is because we have to modify a little bit the action button code here, and we have to take into account that we don't have this argument in place, so we have to do it our own. So let's use who.geometryType.points, and also for this one we use 0, and this is also not going to work. I'm going to show you why. Let's apply that, and it now won't throw an error, but you are not seeing the points, so you see the original input geometry, but that's not what we want. We want to see the actual scattered points. And for that we have to do another thing, that is to explicitly point the select group parm function to the node you want to operate on. So for that we are going to use an argument called node, and that will be a pointer to an actual node, and we can do that by using the who.node and pointing that to any path. So let's path, and the path variable we're going to populate right now, and the path will be the who.selected nodes, which will return a list of all selected nodes. We will only use the first one, that is the current node, so we can pass the first index of the list, and from that we are going to get the path. Okay, so if we now apply this, still not working, and that is because I forgot to concatenate to the path, to the base path, this node over here, the big group. Okay, so now we are going to read the point selection from right inside the digital asset from this node. So let's apply and run that again. Okay, so now we go to the point selection, and once we hit enter, we have all selected points. Okay, so let's go from that, and now we have this selection mode, or the second selection mode will be by inputting, by reading those points directly from the second put. Alright, so we'll do another thing, that is just to keep the interface clean. That is, once the user selects by init positions, it's going to hide this group. Okay, so let's do that right now. On this point group tab, you go to tab hide when, and let's put that inside curly brackets, and we'll check the value of the start points mode. So if start PTS mode is not 0, that is by point indices, it's going to hide the tab. So let's apply and test that. Okay, so it doesn't show, and there's a little catch here. If you type here, you need to be sure that you have spaces before each operator, so spaces between here and here and here, otherwise it won't work and it won't throw you an error. So it's a little catch you have to pay attention to. Okay, so all right, now this is the first mode and the second mode, and now we are going to use this parameter. So we are going to use that inside our digital assets to control what is your initial configuration. So we already have the switch in place, and we just have to copy that parameter and paste relative references. Okay, so now we have number 0, or if you we change, let's press P to open this, and if you change this to the second, we have 1. So we have all this already working, and I think we'll probably leave all this painting stuff outside the digital asset also. So we just want to maybe transfer directly this parameter called infection mode from the original geometry. I believe that's going to be it's going to be easier. So let's go outside and just copy that. So this is one way. Let's actually just use the paint for now. Okay, so we're just going with the painted geometry. So subdivide. Oh, I have to. Let's do another paint, and this is going to change the infection multi, and you want to visualize that. Okay, so actually let's put one more subdivision and paint that again. Apply to all. Just paint something. Okay, so we're moving this outside the you can also make another digital asset just for the painting, but I'm going to leave this outside the digital asset for now. So what else we can do? We can do like simulation controls. Let's see, the scatter. Maybe in the initial configuration you have point groups. Let group that even more. Let's put positions, and let's put another type called scatter options. And here we maybe want the total count and maybe relax iterations. And what else here? Infection solver. Let's put some of the solver settings, and that would be into a new tab. And this would be sim, and inside the sim I want to change the search radius, and also the max search points, and also the mean contamination threshold. And as a post simulation tab, we would like to maybe try the blurring iterations, proximity radius, and max neighbors, and that would be inside maybe a blur tab. Let's make it simple, and another tab will be like edges, and inside here we'll do our min and max thresholds for the edge detection. And we also want to put our speed controls. Let's put that right before everything, speed. And then as a final step, we can also create another tab and call that visualization or debug or something. And this is going to have maybe this input, or actually let's do that differently. Let's create an ordered menu again, and the label will be visualization color, and that will have 3 items. The first one will be initial points, the second one will be infection, and the third one will be the edges. So let's apply that and go to our debug, copy this parameter and paste into the switch input. And I think that's it. Let's accept that and let's see what happens now. So we have our grid, and we subdivided and painted on top of that, and we also have our little point here on the right side. And let's start tweaking to see how the digital asset works. And the first thing is, let's try with point indices. So let's select just a little bit on the side and it works, or maybe by point positions. And if we are using point positions, let me do one thing, that is to create another folder here, and this will be called like point positions. and this will control the radius of the search radius, and the search radius is this this value here. And again, we will do the same thing we have in this one, just so that we keep things consistent. So we're going to hide when is not by initial positions. Okay, so let's apply and test that again. So if by initial positions you have the search radius, and if by point indices you have the group to pick. Okay, so group is working. Yes, by init positions you have that reading this. If you add another point, we can have many points, and we have also the search radius control. Okay, and also let's do point indices again. So on the scatter options we have the number of points, so we can tweak that. And also let's up that, relax iterations. And on the simulation side we have let's do that again for the positions. Let's use our initial positions. And let's go to the simulation controls, and actually let's set the debug to infection so that you can see the effect. And let's try and not blur that for the moment. And also let's set the speed to maybe 5. Okay, so another thing, let's try and lower our contamination threshold. And also let's add just a little bit of value to this infection multiplier. So let's do just a little bit, and apply to all, and then paint again with our white color. Just so that it spreads to every direction. Okay, so now we can play with the settings. So we can try lowering the search radius. Post simulation, we have let's simulate again. So here we can play with the speed, we can play with we can blur our result, and we also can change the edges. And to see the edges, we can change our debug visualization color to edges, and we can tweak that here. And we can also select everything. We can do many effects with this, and we also can see it playing. And here we can see some other uses for this technique, that is to like transfer the infection attribute to an activation of rigid bodies, so you can like make pieces fall from the infection. And another example is like using the effect to drive a mountain slope on a grid. So we have something like this, and I'm also using the edges to emit particles from that. So with a fancy render, it could look something like this. And yeah, that's it for this tutorial. Long tutorial, but I hope it covered all the things I have planned for you. And let me know what you think and what are other topics that you want me to cover on the next videos. And also let me know in the comments if you like that, if you think it's too long, or if it's too, or if you want shorter versions of, if you want me to split into many tutorials. And I hope that you enjoyed, and thanks for watching. We see you in the next video. Bye bye.